Hi everyone, is an introduction of how to prove theorems about perpendicular lines with a lot of vocabulary. So basically, the distance from a point to a line is the length of the perpendicular segment from that point to the line. So this is key. We have two theorems here, Theorem 3.8 and 3.9. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So angle 1 is congruent to angle 2, so G is perpendicular to H here. And in Theorem 3.9, if two lines are perpendicular, then they intersect to form right angles. So angle 1, 2, 3, and 4 here are right angles. So in the diagram at the right, angle 1 is congruent to angle 2. So what can we conclude about A and B? Well, by Theorem 3.8, that means that A is perpendicular to B. And here's another theorem. If two sides of two adjacent acute angles are perpendicular, then their angles are complementary. And so, for example, AB and BC are perpendicular, so angle 1 and angle 2 are complementary. And here would be a proof. In the diagram, angle 1 is congruent to angle 2. And we want to prove that angle 3 and angle 4 are complementary. So we write down the given. And the reason that PS, line PS is perpendicular to PQ is based off Theorem 3.8. So if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. All right, and so therefore angle 3 and angle 4 are complementary, and that's our proof line, and that's based off Theorem 3.10. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. All right. Here's some more examples. If C is perpendicular to D, what do we know about angles 3 and 4? Because these are perpendicular, all of these angles are right angles. Therefore, the measure of angle 3 plus the measure of angle 3 equals 180, because these are all 90 degrees, right angles. All right, and I didn't put example 2 diagram, but we can also prove that they're right angles. We have two more theorems, perpendicular transversal theorem and lines perpendicular to a transversal theorem. So if a transversal is perpendicular to one or two parallel lines, so here's your transversal, then H is parallel to K, and J is perpendicular to both H and K. And the other theorem, in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So that's that. Is C perpendicular to D? Are these, parallel? Yes, they're parallel because C and D are both perpendicular to A and C by Theorem 3.12. Is B perpendicular to D? And so that's right here. Is it perpendicular? Yes, because B is perpendicular to C and C is perpendicular to D. So that's by Theorem 11. So here's a little example where you can draw conclusions. There have three lines, and they're all perpendicular, and so you get a lot of parallel lines. You read that. And finally, we have example 4. We have railroad tracks here, and we want to find the width of the tracks. So basically, we want to find the distance, say, between this point and this point, since it's given. So we need to find the length of the perpendicular segment, and we're going to use point Q. So Q is 71,34, and R, these two right here, which is 91,55, and to find the slope. So to find the slope, of QR, you get this, and you find the slope of PQ, this one, and you get negative 20 over 21. These are perpendicular because the slopes are negative reciprocals of each other. And then you just use your distance formula to find the width of the track here. So we have an example. It says, what's the approximate distance from line M to N? So it's right here. These are your 2 points. So what we'll do is we'll call point M, let us call that point 1, is negative 2, 3. And I'll call point 2 is 1, 2. And then you use your distance formula. So the distance formula equals the square root of x2 minus x1 squared plus the quantity of y2 minus y1 squared. And we'll just let our 2's be our x2, y2, and the 1 is going to be the 1. So our distance is going to be, it's going to be 1 minus a negative 2 squared plus 2 minus 3 squared, which equals the square root of 3 squared plus negative 1 squared, which equals the square root of 10. So that's approximately 3.2 units. And that's it. Thank you. Have a nice day. Bye-bye.